Hello and welcome to another video. Now, if you've been keeping up to date in the build series for the Tiny Barn, you'll know that the very next stage is to prepare and install the steel reinforcement bar for the retaining wall and get the concrete poured. But to do that, we need a rebar bender. Now, earlier on in the year, I designed and made this rebar bender, and you can see that video here. I'll also put a link to it in the description below so you can go and check it out. And importantly, at the end of that video, I identified a few design flaws and problems that presented themselves when I used it to make this retaining wall. So let's get this over to the workshop and make those design improvements so I can use it to knock out the steel reinforcement for this retaining wall. So if you watched the video where I built and then used this rebar bender, you'll remember that this pin diameter was the problem. Now, I had designed this plate, this removable plate, to keep these two pins the correct centers apart, and it actually works really well. But this plate falls off far too easily, and when it does, undue stress is placed on this pin because of this roller, and it causes this to bend. So you can see there, doing two 90-degree bends, has actually pulled the pin over about 1/8 of an inch, 3 millimeters. So what am I going to need in order to make these improvements? I'm going to do away with this plate. I'm going to bore this out to the same diameter as this pin here. I'm going to replace this pin and replace these two gusset plates. So we'll need some 3 or 4 millimeter steel plate in order to replace these gusset plates. And I'll need a piece of 22 millimeter diameter bar in order to replace this pin. And then it's just a case of shaving this back. So let's head over to the scrap bin and see if I can find the resources I need to make these changes and improvements. I can see there's a piece of bar or plate here, which is about 3 millimeters thick, so that could potentially work for one of my gussets. I can see this piece here, that's about 3.5, a little over 3 maybe. Just over 3, so 1/8 of an inch there. That could work for both of my gussets, so I'm going to swap that one out, put that one back. Do also have these pieces of square tube, square hollow section, but they're actually too thin, so I'll put that one back in there. Going to be using this for my gussets. Now I just need a piece of bar for the pin, and there's a piece of bar right there. That looks like it could be the right diameter. Let's check this out. Yeah, 24. I can turn that down to 22 millimeters. That'll be perfect. Okay, good. We've got what we need. This is the part that we're modifying here. We're going to take off these two gusset plates, but we want to maintain the same centers here to here, which is around about 68 according to this here. And if I just confirm that measurement on this side, I would actually say it was probably 70. Let's go with 70. I'm sure I would have made that a nice round number. This gusset that we need to replace is going to be curved to match this boss. It's going to be pulled up straight like this, curved around for our new 22 millimeter pin.
And it's worth just taking some time to take a few measurements from this assembly before I start chopping it into pieces. When it's in little pieces, it's going to be very hard to remember how far apart all of the features need to be. So I'm taking all the crucial measurements plus anything else I think I might need, and that way, once I've chopped it up, it's going to be easy for me to make the new parts. I'm using a cut-off wheel in an angle grinder, and these are only 1 millimeter thick, so they cut really quickly and efficiently. Then swapping over to a sanding disc will make really short work of what's left of those gusset plates and the very hard material which was the weld. I'm just trying to get this back to smooth. I don't need it to be perfectly round, I just need to have a good clean surface in order to reattach and re-weld the new gusset plates. Now I've got both those gusset plates marked out on the material, just center punch them, get them over to the drill press and use the 50mm diameter 2-inch hole saw, which will give me the matching profile of the center boss that these will be welded to. Now you may have noticed there's quite often a lot of background noise. This is a busy school workshop and there's a lot of students around trying to finish off their project work. Fortunately, I've managed to stay out of everybody's way and get the modifications completed. So this gusset plate has a 22mm hole in it to accept the new bigger diameter pin. However, the other gusset plate, the pin isn't going to go all the way through it. It's going to butt up against the surface and be plug welded. So I'm just drilling this with a 10mm drill bit, and that will give me enough space to get a good strong plug weld in. Now the only crucial measurements on these gusset plates is the diameter of the holes and how far apart they are. The outside shape of the gussets really doesn't matter. So I'll quickly shape them up with a cut-off wheel and then finish polishing them with a sanding disc. Now I do have to admit, drawing these up on CAD and having a CNC plasma cutter cut them out for you would be something truly special. However, you don't need that kind of equipment. Basic hand tools is all you need and you can manufacture pretty much anything. And as I said, the exact shape of these gusset plates really isn't important, but the holes do need to be concentric, you know, they do need to line up with each other. So I'm just doing this by eye and then tracing around it, and that way I know that the pins are likely to be parallel when I weld it all together. Well, that's the two new gusset plates made. Now I need to make the 22 diameter pin that goes through the gusset plates and ultimately support the roller that bends the rebar. And the piece we found earlier is a little bit short, as you can see here. But I do have a solution to this and I'll show you what that is later on in the video. So let's get over to the center lathe and we'll start by facing this material off and then turning it down to the correct diameter of 22mm. Well, rather than taking measurements of the diameter, I'm just using the hole in the gusset plate that I've drilled as a template and as a guide. Once it fits nice and tightly, then I'll finish machining the shaft down its entire length. That's the pin machine down to the correct diameter of 22mm. Now to use the center drill to make an indentation or pilot hole, then I can drill and tap that hole for an M6 bolt. I'm going to be using this to hold a washer in place that'll prevent the roller from falling off the pin, and you'll see this later on in the video. A small amount of cutting oil, and then run the M6 tap into the hole to create the thread. And I'm only going 15 or 16 millimeters deep, about 5/8 of an inch. This washer you see here is the wrong size, so I will need to make a custom washer soon to suit this bolt, and you'll see why a little later on. But first, I'm going to put the pin into the gusset plate, and I can then align it with the center boss and determine just how much of these side plates I need to shape. And it turns out it's only the front plate that I need to modify, and it's a tiny amount, round about 3 millimeters, 1/8 of an inch. So I'm using the cut-off wheel to remove that material, and then I'll bring the sanding disc in and just polish that up and get it nice and smooth. I'm just trying to create enough clearance so that the pin doesn't rub against this plate as the tool is operated. Spending some time making sure that the pin and the gusset plate are perpendicular to each other is important. I want to make sure that as this tool is operated, the pin and the center boss remain parallel to each other. So making sure this is perpendicular, square, before I weld it in place. If you remember at the beginning of the video when I found this material for the pin, it was a little bit too short, and so the solution was to plug weld this second gusset plate in place. Now once that plug weld's gone in, there's no breaking that free. So a small tack weld, check to make sure it fits before finally welding it.
Right, that looks pretty good.
Now the final component that needs modifying is the roller. Now this is the original roller with the 12mm hole through the center that fitted onto the original pin that was bending. That chatter and vibration really isn't a good sign. It tells me that I'm trying to drill at too high a speed. So switch it down to the low gear and then dial it up to a speed so I'm getting a nice vibration-free cut. I need to bore this out to match the new pin, 22 diameter, but this is the largest twist drill bit I've got, 16mm, 5/8 of an inch. So I'll use that and then switch over to the boring bar in order to open it up to the required 22mm.
Now I need to make a washer to keep this roller in place, and so back to the scrap bin, see if we've got a piece big enough. The outside diameter needs to be bigger than 22 and it needs to be solid bar, so I can bore it to 6.5, and there's a piece. What have we got here? 21, 22, which means this is bigger, 25. 25 should work. So I'm going to face this off, bore it to 6.5 or 7mm. Let's check this out. 6.5. Face this off, bore it to 6.5, chop it off maybe 5mm thick, and there I've got myself a custom washer. Take the edge off. Use the center drill to make a mark. Swap over to the 6.5 drill bit. Bore a hole. Now if I had a parting bit, I could just chop that straight off and we'd have our washer finished. But I don't. So, chop this off in the bandsaw and see if we can get it in the lathe just to face off the back face. Only needs to be quite thin. That should do the trick.
Cutting without coolant means this part's really quite hot, but I want to get it onto the lathe quickly so I can face it off and get this job finished.
Now if I had some slips in the back here, I could guarantee that these two faces would be parallel. I don't have any slips. So I'm just going to have to do this literally by eye. That actually looks quite good. So I'm going to snug that up and just take the smallest skim off the face.
And there we are, just need to take the sharp edge off the back and it's done.
So the purpose of this little washer or spacer is to be able to prevent this from sliding off. Now that that's in place, I can locate this on this main center boss, weld it in place, and the modifications are finished.
So I've estimated the position of where this roller should be in relation to its rotation around this central pin. And I think I've got it right. But the real check is if I raise this all the way up until it hits the stop and slide in a piece of bar against the stops until it makes contact with that roller. I don't want it to touch or be inhibited by the roller. And as you can see, if I slide this bar in and out, it is just making contact, just rolling it a small amount, so it's in the perfect position. So I can go ahead and fully weld these two gussets in place. You can see here how the old grease has been burnt off by the heat of the weld. So, now in the final assembly stage, get some fresh grease on there, pop it all back together, and get ready for its test.
I will need to find the split pin just to hold this one in place, but other than that, that modification I think has worked really well. Of course, the proof is in the testing to see if it can actually bend this bar. So let's try it out. So it's been re-greased, reassembled. Let's see if those modifications allow us to bend this 12mm mild steel bar to 90 degrees and beyond. Well, that's good. Slightly beyond 90 degrees, which is exactly what I wanted. Absolutely perfect. However, I don't like that could move. I am concerned that just a split pin in there might not be sufficient. Let's see if I have a bolt. What size hole is that? So if I can find an M6 or M8 bolt, we should be in business. Well, all I can find is an M8 bolt, and it doesn't go in the hole, so that means I can just tap this M8, thread this in, and that will just stop this falling forwards. I think I'm going to give it a go because it's a really quick, simple fix. I've just ran an M8 tap through this hole that the split pin used to run through, and I'll be able to just put the bolt in there and hold it all together. There we go. A roller now can't fall off the front of the pin, but it still rotates. I'll give it one more go. Look at that, perfectly aligned. I think that is a really successful modification to this. The proof will be in how well this performs on the steel reinforcement bar for the new retaining wall. Let's get this back home and try it out. Well, I've been using this now for quite a few hours, and these improvements really are improvements. These rollers don't fall off, nothing's bending, it's accurate every single time. So although the Rebar Bender 2.0 is a roaring success, there is one more improvement I really feel I should make, and it's to do with this handle. It's a square hollow bar, and it's got relatively sharp corners. Now, if this becomes unbalanced, and it does occasionally, this has a tendency to hit you in the head. And it's a sharp corner. So what I think I'm going to do in the future is chop this back maybe 100, 150 millimeters, weld in a piece of round tube and put some heavy duty rubber guard on there. So I have a rubber handle, nice to use, but more importantly, when it clonks you in the head, it doesn't hurt. So I'm very pleased with those improvements. Now to get on with the reinforcement for this retaining wall, so that we can get some concrete poured. So until next time, thanks so much for watching. Bye.